Alright, so here's my web shooter explanation video for WDM4.3. I wanted to make this so we could sort of be on the same page in terms of the web shooter design. Plus, if there's any obvious design problems with this, let me know. There are some problems that kind of look like they're present, but I've fixed, so I'll let you know when we come to that. So first off, this is the WDM4.3. I've told you that the WDM4 is modular. So this middle piece is the WDM4. It's basically this main unit, the secondary unit, and the trigger. Plus, the straps, possibly. And essentially, that's the parts that won't change between designs. So WDM 4.1 was basically just the fixed version of the WDM3, which is the one with the flask pressure vessel that I showed in the previous video that I made on the web shooter, the actual physical one. That was called a small web shooter update, I think. But that was sort of the updated version of that. WDM 4.2 was basically this main unit with these two parts here plugged, but then you would have one CO2 canister coming out of here with the fluid on top of it. So you would have fluid CO2, plug, plug, and then it would go up and shoot out. But that was very low fluid capacity, so I decided to go with this. This originally started out as a Scarlet Spider sort of thing, and it evolved away from that, and then evolved back into it, and now it's sort of in between. It's sort of in between a realistic and a Scarlet Spider design. So, let's go over the different parts, just primarily what I need to and don't need to explain. So right here is the trigger, the wires, and the nozzle. I'm pretty sure they don't really need any introduction. The trigger is just a button, the nozzle is just some kind of, probably a barb fitting for the output. This trapezoid here is just an extension that I'll have to build or 3D print for the main unit. This right here is what I call the main unit, and that's where the formula combination and the actual chemistry stuff happens. So I'll show you the inner workings of this a little bit later. It's on a separate page, but basically you can see there's two solenoids. So I know we talked about the singular solenoid, but after I saw the issue with the one that you had sent me before, I started looking for some other ones and I could not find any. I think that you said that you couldn't find any either. So yeah, that would be an issue with the singular solenoid. So I'm probably just going to end up using two. But down here you have the two T pieces that sort of come out of each side of this. And the point of these is to just allow for two pressure vessels to go into it so that we can have more fluid capacity. Now, the problem here that I originally had was that each of these was a cross piece. So there would be one more input here with one more pressure vessel. That was before I had this secondary unit here. So I had to condense the amount of fluid because I had to add this extra unit here, because these CO2 canisters were below this, directly below it. But I had to move it over, which made it so there was less actual space for fluid. But all of this in here is where the chemistry stuff happens and the final release of the fluid. Right here is basically a ribbon cable. I don't really know what I'm going to use. It's probably just going to end up being all the wires and such put into some heat shrink tubing. I wanted to do a ribbon cable, but then I realized that would probably be very low resistance and very low strength. So down here is where the batteries are going to go. Since we don't really know about the heating part yet, I will probably just be using the two 9 volts. So, as you can see, I have two rechargeable 9 volts here. They probably end up like this, since you have to have a clip for both of them. Now, the problem here is that this is the length of the main unit, and you can see the problem. It's a bit longer, even. Plus, then, if we do the heating coils, we'll have to have more batteries down here, the small 12-volt ones. One or two, depending on the amount of nichrome or whatever wire that we use for that. So I don't really know what I'm going to build for that. Plus, I'm going against using the new circuit for it. I'm probably just going to go back to using the microcontroller because of space. So, next, you see these sort of X parts here. That's just the nylon straps. And what I wanted to do was basically take the nylon straps and sort of weave them around the pressure vessels. So this right here is the CO2 adapter. This originally, like you saw in the previous video that I showed you, as well as the Smalltalks 3, this valve was manually actuated, and you saw that I've already built this adapter. I want to rebuild the adapter and modify the valve so that it won't have to be manually actuated, so it can just constantly, whenever there's CO2 connected, it can be constantly shooting the CO2 into the bottom of the canisters. Plus, I got better caps and screw pieces for them, so I want to make the adapters a little bit better. So, the CO2, when it's connected, is constantly shooting into the bottom of these pressure vessels. And these operate on the GPM, like I said in the Smalltalks episode, and it's going to work just like that. You know, just like you would expect. Now you can see up here I have these two pieces here. These are sort of these threaded pieces that then lead into the tubing that goes into the T. Now you can see I sort of don't have that down here. The problem that I had was that this was basically a closed loop with threaded pieces, which can't work, because if you're going to unscrew it, you would basically just have to turn the pressure vessel, but you can't turn it two ways at once. Now, I mean, if both of these were pointing in opposite directions, if I was turning the pressure vessel, you know, this way, like if I was turning it to try and loosen it, just in one way, this side would be loosening, but this side would be tightening because they're pointing in different directions. So the only way to solve that was to make it so the CO2 injector was permanently connected rather than removable, and the part where the fluid exits, or the part where I would actually refill it, is up here and is able to be taken away. But the only way to do that would be to unscrew this part, which would twist the tubing itself, which is somewhat a problem because that can mess with the integrity of the tubing, but hopefully it shouldn't be too bad. Oh man. So this is basically going to be symmetrical. So you would have, if you looked at it sort of, how could I say this? If you sort of unwrapped it as it was on the forearm, it would be basically this, symmetrical. Only if you were to actually lay it out, since the buckles would be on the bottom of here and here, it would go CO2, like water cartridge, spirit gum cartridge, CO2 cartridge, so that when you wrapped it around the arm, it would look symmetrical. So, that's the basic workings of that. So you know everything about the tubing and all that. So, the workings of the inner main unit are as follows. Here's where the spirit gum would come in, and here's where the PVA would come in, or rather just the spirit gum or whatever water-based solution we have. So, each of these T pieces and each of the solenoids only controls one ingredient. The only time they ever come together is up here after they come out of the solenoids into the spinneret. The only problem is that there might be clogging on the spinneret, but obviously at some point there will be a combination of the two formula ingredients, and inherently there will be some clogging possibility. So I wanted to make it as late as possible for them to combine. So basically, let's just follow the path of spirit gum just on the left here, because it's basically just mirrored for the PVA. So we'd come in here, come up through this elbow piece, and then right here I have just a sort of small threaded nipple piece that then is glued in to this heating coil here. The wires for the heating coil would then come down here, but then you also have the sort of copper tubing, and that's sort of coiled up like that. So the fluid comes in here, comes up into the coil, spins around, comes up into another threaded piece, goes into the solenoid, which closes it off until it's opened up, goes up into the spinneret, and goes out. So, what are the issues with the inner unit? Well, the main issue is that, once again, here, with the spinneret being a singular point where they're combined, just like the T's themselves, is a closed loop. So, basically what I would have to do is screw the threaded piece in here, screw the threaded piece in here, somehow get the, or actually, I would have to take the spinneret, have it just have two threaded openings, take a nipple with a sort of hex nut piece on the middle, which exists, and I would have to then screw it in there, unscrew it slightly, screw the solenoid on, screw one of them on, disassemble this solenoid, screw it on so it can actually rotate and not hit the other one, reassemble it, screw in this threaded piece here, screw in this part here so that it comes together, have both of these threaded pieces here, insert the heating coils, glue it in, screw this threaded piece and this threaded piece into the elbow pieces, and then sort of enclose it and glue it. Or, epoxy it or some adhesive. Which that's going to be a hassle, but that's really the only way to do it. So, that is the basic workings of the shooter. If there are any obvious problems or if you have any questions, once again, just let me know as usual in email. So with that, thank you for watching, Robbie, and Spider Device, Dalton out.